Hello everyone, myself Mantisha Hassan, and today we are going to discuss about the most important topic of chemistry, that is quantum mechanical model of an atom. So what do you mean by atomic orbitals and what do you mean by quantum numbers? So we have set of 4 numbers which give a complete information about the electron in an atom, that is its energy, shape, orientation and also its spin. So they are known as quantum numbers. So we have 4 different kinds of quantum numbers. First one is principal quantum number, second one is azimuthal quantum number, third one is magnetic quantum number, and fourth and last, that is spin quantum number. So what do you mean by principal quantum number? Principal quantum number is denoted as n, and the maximum number of electrons which could be filled or accommodate in this particular shell is 2n square. So we have 4 different types of shells. First one is K shell, second one is L, third M, and last but not least, that is N shell. So K, L, M, N. So what is the maximum number of electrons which we can fill in these particular shells? They are as follows. So we have in K shell, we have number of electrons is 1. So the K shell will accommodate 2 electrons. In N shell we have maximum 2 electrons. So the maximum number of electrons which could be accommodated in L shell is 8 electrons. Third one is M shell, and in M shell the value is of n is 3, so we can accommodate 3 square, that is 9 into 2, 18 electrons, and in N shell we can accommodate 32 electrons. So I hope you got the point of principal quantum number, which is denoted by n, and the maximum number of electron which we can fill or accommodate in this particular shell is 2n square. Now the second one is azimuthal, which is also known as subsidiary or angular quantum number. It is denoted as L, and the value of L depends upon the value of shell, that is n, and the value of azimuthal quantum number ranges from 0 to -1, and L represents the subshell, whereas principal quantum number, that is n, represents the shell, and azimuthal quantum number L, it represents the subshell. Now in K shell we have n is equal to 1, so L will be equal to 0, that is we have one subshell. N is equal to 2 in L shell, so what the value of L is minus 0 to minus n minus 1, so we have L is equal to 0 comma 1, that is we have 2 subshells. In N is equal to 3 we have M shell, and L की value हो जाएगी 0 comma 1 comma 2, that is we have 3 subshells. And in N is equal to 4, that is N shell, we have L is equal to 0 comma 1 comma 2 comma 3, so we have how many shells? We have 4 subshells. I think you got my point of azimuthal or subsidiary or angular quantum number, which is denoted as L, and the value ranges from 0 to -1. Now the subshells are designated as S because L is equal to 0 in S shell, and L is equal to 1 in P shell, and L is equal to 2 in D shell, and L is equal to 3 in F shell. So we have mentioned about the value of N and the value of L and the name of subshell and the number of subshells. So if the value of n is 1, the value of L will be 0, and the name of the subshell will be 1s. And if the value of n is 2, so the value of L will be 0 comma 1, and the name of the subshell will be 2s comma 2p. If the value of n is 3, so we have value of L is 0 comma 1 comma 2, and the name of subshells will be 3s, 3p, 3d. If the value of L is 4, so the value of L will be 0 comma 1 comma 2 comma 3, and the name of the subshell will be 4s, 4p, 4d and 4f, and the number of subshells total are 4. So this is about azimuthal angular quantum number, and it is easiest. Now next is azimuthal quantum number gives orbital angular momentum of the electron present in any subshell. Means if you are talking about azimuthal quantum number, then we will also get about the angular momentum. So the formula for angular momentum is under root L into L plus 1 bracket close into h upon 2 pi. For s orbital, the value of L is 0, so the value of L will be 2 under root 0 into 0 plus 1 h upon 2 pi. So anything multiplied by 0 is 0, so the value of L would be 0. For p orbital, L is equal to 1, so the value of angular momentum will be root 2 h upon 2 pi. For d orbital, L value is 2, so the value of angular momentum is root 6 h upon 2 pi. For f orbital, the value of L is 3, so the value of angular momentum would be under root 3 into root 3 plus 1 h upon 2 pi, that is root 12 upon root 12 into h upon 2 pi. So you have to revise these formulas, that is the angular momentum of an electron is under root L into L plus 1 into h upon 2 pi. Now the next one is magnetic quantum number, which is denoted by M. Now for a given value of L is what? Azimuthal quantum number. So the possible value of L varies from minus L to 0 and min to plus 1. So the total value of M would be equal to 2L plus 1. Now we have value of L, the name of subshell, the value of M and the name of orbital. So if the value of L is 0, that means the electron is present in which subshell? The electron is present in S subshell. And the value of M would be 0 and the name of the orbital will be S orbital. If the value of L is 1, this subshell is P and the value of M will ranges from minus n minus 1, 0, plus 1. So the name of orbital would be P orbital. If the value of L is 2, the name of subshell is D and the value of M will vary from minus 2, minus 1, 0, plus 1, plus 2. If the value of L is 3, so we have F subshell and the value of M will vary from minus 3, minus 2, minus 1, 0, then plus 1, plus 2, plus 3. So the maximum number of electrons which can be accommodated in a subshell is 4L plus 2 and the maximum number of orbitals in a subshell is 2L plus 1. So these two formulas you have to revise from the bottom of your heart. Now the next one is spin quantum number. Spin, we have two spin of electrons. First one is clockwise and second one is anti-clockwise. If the spin of electron is clockwise, the spin quantum number would be plus half. And if the spin of electron is anti-clockwise, then the spin quantum number is minus half. Plus half denotes spin up of electron and minus half denotes spin down of electron. So what is the formula of spin quantum number? That is under root S into S plus 1 into h upon 2 pi. And if all orbitals are fully filled, then the net magnetic moment would be 0, and if there are half filled orbitals, then the net magnetic moment would be paramagnetic. So I hope it is clear. We have discussed about principal quantum number, we have discussed about azimuthal quantum number, then we have discussed about magnetic quantum number, and last but not the least, that is spin quantum number. So please revise all the formulas and the PDF would be available as soon as possible. Thank you so much.